Stream. Nice. So I think part of the problem I ran into is so welcome, hello stream, hello. Part of the problem that I ran into while streaming is I think there's a preview, like I create the stream and I put a time on it. And I think I need to remember to not put that on, put the time on it, because I have a tendency to like spend like an hour or so just kind of hanging around, checking things out on the internet before I actually start the stream, which is kind of weird, but I don't know, I kind of like to just relax a bit and lay down on my bed or like go see what people are doing on Twitch, which is kind of weird, and I probably should stop doing that. It's like sinful, the stuff on Twitch is extremely like the stuff that I check out is lascivious, and I shouldn't be doing it. Yeah, it's like I already know, like I know what the story is. Like it's nothing to gain really. There's like a little bit to gain in that there are other people there that I'm sort of interested in paying attention to, but not a ton of attention, just enough, I guess, I suppose. Yeah, there were at least a couple girls that I think were interested. One that's actually talks about God, and another one who I don't know what her deal is exactly, but I think she liked me, so that was interesting, I suppose. But I think she also may or may not be single anymore. I don't know. She's seems like she's on the fence about it, which is, I don't know what to make of that exactly. But anyway, what we're doing today, sorry, I'm kind of like talking about something totally unrelated. What we're doing now is the things that distract me in my mind. The distractions, my excuses for why I'm not like pumping out videos, I guess. So we're going to take a look at this problem and try to solve it in Clojure. And yeah, that's it. Just get going. So, given a 2D array of digits or grid, try to find the occurrence of a given 2D pattern of digits. For example, consider the following grid. Okay, 2D pattern of digits. Assume we need to look for the following 2D pattern array. 2D pattern begins at the second row and the third column of the grid. The pattern is said to be present in the grid. Huh. Function description. Complete the grid search function in the editor below. It should return yes if the pattern exists in the grid. Excuse me. Or no otherwise. Grid search is the following parameters. G, the grid to search, an array of strings. P, the pattern to search for, an array of strings. Input format the first line containing integer t, the number of test cases. Each of the t test cases is represented as follows. First line contains two space-separated integers r and c, indicating the number of rows and columns in the grid G. This is followed by r lines, each with a string of c digits representing the grid G. The following line contains two space-separated integers r and c, indicating the number of rows and columns in the pattern grid P. This is followed by r lines, each with a string of c digits representing the pattern P. Constraints: 1 less than or equal to t less than or equal to 5, so 5 test cases. Sample input 2, 10, 10. What is RRCC? Number of rows and columns in the grid G. 10 by 10. Excuse me. It's followed by R lines, each with a string C digits representing the grid G. The following line contains two space-separated integers R and C, indicating the number of rows and columns of the pattern grid P. So this is the pattern. So these are the two tests. So we get two test cases, and this is the grid. for the first test case, and this is the pattern of the first test case. So we're searching for this pattern in this grid. And similarly, this is the second grid in the second test case, and the second pattern that we're looking for within this grid. Okay, so now we're looking for, okay, fair enough. And we want to do this somewhat efficiently, and explain it. So this is a kind of neat question. The solution. Now the thing about this problem is this is an interesting question. Not really obvious how to solve it. I'm thinking you probably want to do something that's similar to like a string search. Now I don't know, what are the constraints actually? If these constraints are manageable, then this is relatively easy. All of this is bounded by 1,000. Oh, that's not easy at all. Wait a minute. 1,000,000? Even a linear time algorithm is going to be kind of expensive. Oh, actually, no, 1,000,000 works. Excuse me, I take that back. 1,000,000 is fine. Watch me wipe my nose here. So this is kind of interesting. It's RRCC. Oh yeah, no, 1,000,000 is fine. That actually can work. That's okay. Linear time. Yeah, that's actually okay. But the problem is, I mean, the problem that you run into is that it's not so obvious how to do a linear search through this. I almost want to say you can maybe use a modified form of the KMP, the Knuth-Morse-Pratt algorithm, to find this. Oh, I have an idea. Oh, I know what to do. Ah, very clever. You can use modified Knuth-Morse-Pratt. The way you do it is you unravel. Oh no, you can't. Can't do it that way. Never mind. I was gonna say you can interpret the grid as a one-dimensional grid, one-dimensional values, and then search for the string using, right, and make this one-dimensional as well. And the problem with that though is that there are a lot of different positions that this could be in, and that actually corresponds to a lot of different possible strings. So that doesn't work. But that'd be a nice hack, nice kind of a hack to solve this efficiently. That would have been cool. But the problem is that these end up in the way. Like you can move this over. And well, actually, no, doesn't matter, right? So if you move this to the left, there's going to be, anywhere you move it left to right, there's going to be 4 characters between this and the next row, right? There'll always be these 4 characters, because if we move this to the left, you gain a character here, this 3, but you lose a character here. So actually you can use a kind of regular expression you build out of this string. Yeah, you can use a regular expression search. The same thing if you go move this up. So you move this up and to the left, it's still 4 characters difference. it doesn't matter if you move it up. It only matters if you move it left or right, but the characters stay the same. Oh, that's cool. That's neat. So you just have to have this 1, 2, 3, 4, 5, 6, and then there's these 4. This is the difference between big R and little r. You just need to have between each row in the regex that you search for. You just need to have between each row when you concatenate the regex that there is that difference in sort of any possible character. Use like the dot character, I guess it would be called. And yeah, that's pretty much it. I think you just do that. And build the regex that way, and then you search, make this one-dimensional, make that regex one-dimensional, and then search for the regex within this array, and that should give you a linear time algorithm that's rather efficient. Cool. I feel like a genius with this now. It's kind of an easy question, I guess, if that's the case, but let's see if we can figure out how to do that in Clojure now. I think it uses the Java regex library, so we'll see how we do that. So I think what we're going to start with is, holy smokes, look at this. Okay. All right. anyway, I'm looking at like the, whatever you want to call it, the all these defines here, all the stuff going on. Grid search GP. All right. What is G and P? An array of arrays, I guess. P is an array of arrays. Okay. What are these? Let's print these. Okay, what happens when I do that? Do I print both? So that'll be the plan. We'll build the regex, and we'll make both of these things into a linear. Yeah, they're just a whole bunch of arrays of numbers, it looks like. Okay, that's fine. So let's start with let, and we're gonna say first we're gonna have this function. I'm gonna say grid 2D grid to 1D grid. Take as an argument the some grid G, and we'll say what we want to do is just concatenate, I think, the whole thing into a single string, which is going to be, which will look like what? Clojure string join of G, I think. And I don't know if G is if these are parsed integers, so they're integers. So we don't want them to be integers, we want them to be we're going to just throw this in here that will also apply what do they call that, string to each of these, or just map string. So convert these integers to strings, join these strings in a one-dimensional grid, and then we're going to 2D pattern to 1D pattern, similar kind of thing. P grid, we'll call it. Now here's the tricky thing. We want to get we want these two values, which would be pgrid and I guess lgrid size, or there's like a grid, we want the grid size of, it's actually a tuple of we could just do RC, I think is fine, or even a vector returns, yeah, return a vector, and let's call this, so big R, big C, right? I think that works. So a destructor, and we're gonna get I'm gonna say grid dimensions on a function. And what we're gonna do is, so we're gonna try to actually do things as functional as possible, right? So we're not gonna use defined variables. We're gonna define functions and use those functions. And this will have a grid as well. And this is going to return the it's going to look like this. It's going to be RC, which is rows, columns. So the number of rows is count of the grid, and the number of columns is count of the grid of get 0. I'll do it this way. 0 of the grid. Right, what is the default? Just 0 count. Right. Right, if this is out of range or something, just returns the default. And this could be empty, yeah. So grid dimensions we'll get. So get pgrid, RC, which when we call this, we're going to use the grid dimensions of G. And then we say, we can do this too. Actually, we can just do this on both. We call it. We have little big C, little RC, and big RC. So the pattern grid, and then these other two. I think it's fine. Try not to declare any variables as much as possible. Just declare functions. And so now what we want to do is say, okay, we've got our grid. We've got big RC, little r, and little RC, and we want to say Clojure. So this is going to be a regex pattern. Clojure.string join of map string onto pgrid, right? And we're going to join this with a dot, which is also this. So we're actually going to return a string, which is, we want, so if we go to Java regex, let's take a look at this quickly. Let's use a cheat sheet also. JRebel. May need some help with the regex expressions here. Okay. So we want a dot, but we also want a number of these dots, certain specific number of them. Greedy qualifiers, reluctant. So exactly n times, yeah. Okay. So this n, it's going to be, I'm going to build this regex. So this will be like this. The value inside is, it's going to be like a string, this with this, and string of the difference between big R and little r, right? So that gives you an integer. Get this string concatenation and a dot. Right. Well, we could do like this. I think this is good. A dot is fine. So now we've got this regex. We join this whole thing as a kind of regex, and let's do this. So just so this is a little clearer. Now this we've got to use as a regex, which is we can actually just return this as a string. I think that's fine. So this will be the pattern. This will be the reg. This will give us a regex. This will give us the 1D grid that we're going to perform the regex search on, and this will give us our grid dimensions. And so now we can build our solution by performing a regex search, so pattern search. So Clojure string to regex. Now this I'm a little unfamiliar with, and then also Clojure regex. Rematches repattern. Okay. Other useful functions of macros. So a rematch returns the match if any, string the pattern using matches, use regroups, return the groups. Patterns an instance of pattern for use in rematcher. So we can repattern S. Okay, so this will actually create the pattern that we want. We can do refined. Okay, rematches and then let's do refined. Oh, these are good, huh? Complement. Comp partial. Constantly. What do these do? I haven't seen those yet. Printing. Regex support. Pattern. Runtime with repattern. Nice. So this is a read time and this is runtime. Okay, that's what I want. So we want repattern. We can do refined, I think. Alright, I should read this again at some point. This is definitely useful. Constantly returns a function that takes any number of arguments, returns X. Cool. That's item potency. And then complement takes function F and returns a function F of n that takes the same arguments as F, has the same side effects of n, and returns the opposite truth value. Oh, interesting. That's kind of cool. Neat. Neat. And then refine is what we want. Returns the next regex match if any. I guess it returns nil if there is any. If there isn't any. So we'll repattern and refind of repattern of what we return, and we want to refind of that pattern, and that's going to be here, right? And then we say this result, we say yes or no, right? So if it's true, we return yes, if otherwise no. So we're going to have also an if statement here. Say if we find this pattern, then we return yes, otherwise no. Okay, and the functions we're going to use in this refined, we can say do the two what do they call that? You know what we can do? Let's do that. Yeah, that's better. We'll do two tabs, and this is on the next tab as well. So that's the find, refind, and then pattern. Wait, oh, mistake. This has got to be here. Yeah, there we go. Okay. So this pattern, this we can put on one line, I think. But we're going to use this 2D to 1D grid. It's going to be 2D pattern to 1D pattern. And we're going to make this function call. And we're also going to use the P grid, which is P. And we're going to use this grid dimensions twice, which we have. Yeah, so that's one of the reasons I wanted to do this. Different arguments. Actually, this function just has 2 arguments. That's okay. It's 3 arguments. Okay. These arguments are going to be grid dimension, G and P for, what do you say, little r, big RC. So little RC is going to be the pattern, big RC is going to be G. There we go. So we refine, we're going to use this pattern, repattern, we build our pattern using 2D pattern to 1D pattern, given this pattern grid and the dimensions of that grid and the dimensions of the larger grid. And then we have the string to search in. So just double check refined Clojure M, R, E, and S. Yeah, so the regex comes first. Regex comes first. And then the string that we're searching in is 2D grid to 1D grid. Or just 2D grid to 1D string, call it. Should be 2D, really grid to 1D pattern, then 2D grid to 1D string. All right, and that just takes a single grid, which is G. That should be grid, not G. These functions are somewhat, yes, these functions are self-contained. And then, that's it. That's it. Functional. Does it function though? Wrong answer. Number format exception, valid number, 2D grid to 1D string, compiling. Interesting. List reader. Where did that occur though? 12.0. Valid number. Hopefully, I don't know. Uh-oh. Invalid number 2D grid to 1D string. Invalid number. Join string grid. Is it? We just did this. What happened? Okay. So it's not calling that's the problem. It's something else. Is that just, oh, you can't start with a 2, I think. Probably the problem. That kind of sucks. could just do grid to pattern at this rate. Wanted to be kind of cute, cheeky with the. Probably wanted to use those numbers in front, but it's 1D or 2D, but it's not really necessary, and also apparently causes issues. So let's see what we do here. Wrong answer. Both my outputs no. You're kidding. Really? This 9505 doesn't show up. I thought it would. I thought it would. Expected output, yes. Where does it show up though? Oh yeah, it's here. 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6. So that's 6, and this is 1, 2, 3, 4. Or maybe it's columns, not rows. I should be taking the difference of. Yeah, I think it's supposed to be the other way around. It's supposed to be C minus C. It's my mistake. My mistake. My mistake. And we don't need the. Actually, this is incorrect because we actually don't want to map this to the whole grid. We want to map this to no, it's a problem because if the thing is all the way to the bottom right, we're missing the characters. We don't actually need. Yeah, we need to actually not append this. Oh no, this is fine. No, this is the join works properly. It just has to go in between all of them. It doesn't have to go at the end. Or yeah, okay, no, that's fine. All right, let's see how we do. Let's see how we do. Get some timeouts or something. Oh, so close. What happened? Really? What's wrong? What's incorrect here? You're kidding. Huh. Wow. That's kind of unfortunate. I mean, okay. Let's get this test case, let's save it to a file, let's load it up in our editor here. Oh boy. Alrighty. Alrighty. It's fine, everything's fine. It's all fine. I'm not upset. Definitely not upset. It's gonna take a minute to put this all together. So all of this kind of needs to go into the main function now. At least it wasn't a timeout, which may have just jinxed it, but yeah, at least it wasn't a timeout this time around. Okay. So gotta bind this read line. Let's just go all the way back. Just copy this, go forward again. There's one thing here. So we get rid of what's in here. Don't need that. Oh, I mean, okay. Doesn't there? This isn't supposed to have like a. I guess not. I don't know. Okay. Anyway, put all this inside there then. Inside this binding. I don't know what all these are. Get the staircases, man. Get those staircases going. Love me some staircases. Isn't that great? Isn't that wonderful? Okay, so anyway, we can get the input path now. We can set this environment before we run this program. The in pointer and the f pointer. And yeah, that should be good. So where are we going to write the output to and read the output from? I think before I was doing it right on the desktop, so we can just set those environments. Input path. There we go. And output path. Now, I suppose I should be able to reason out what it could be, this test case it's failing, but I have no idea. I mean, I really don't know. Yeah, man, I just don't know. How are you supposed to know? It wasn't a timeout, so that's kind of good. But it's also kind of bad because it's like, well, how? How could this have failed, actually? That's really the question. Where could this have failed? Kind of know where it could have failed, I think. No. There is nowhere that it could have failed. Unless it's like a degenerate case. It's like a really, it's got to be like a real special case. Something, I don't know. So what have we got? Right now it's input 2, so we just save this over. And then where do we write it before? Output. Alright, let's see what happens. $13, $15, $19. Oh. Go ahead and delete this. I don't know where that print came from. Whoa. Macro expanding let not conform to spec. What do you mean? What? When I copied and pasted, I guess I moved something around. No, this is fine. This is fine. What do you mean? What do you mean? It's bad. call didn't conform to spec. No, caused by... oh, this one at the bottom didn't. This let wasn't spec. Okay, yeah, we know that. Can we do this? There we go. Okay. All right. Yes, yes, yes. No, yes, yes. And what we expected was yes, yes, no, yes, no. So the last part is the one that's wrong. The fifth part, which looks like what? If we could be so bold, let's get to the bottom here. This one. Holy guacamole, man! Let's go to this. You just go to our file, the desktop. Take a look at it. What's it called? It's input 2, right? All right. Let's go input 3. Let's go input 3. And edit this. 1,000 by 1,000 lines. And change this to a 1. And then we're gonna just. Well, this is gonna take a while, huh? Holy smokes, man. Holy guacamole. Okay. So I think this is all what we got at the end here. 1,000 by 1,000, 1, and this pattern at the bottom. And apparently this fails. What do we get for input 3? Let's get rid of the output. Delete. And let's say, what's it? Okay, let's see what happens when we do this. So we're expecting it to say, I think we're expecting no, but we end up with a yes. No, what are you doing? Oh, I know why. 3. Let's get what's being written to, so let's give it a moment. Okay. Oh, I'm not supposed to show you my desktop here. Oh, I do have a recycle bin. How did I not find this before? Instinctively, I just knew where it was. I tried searching my desktop before for the recycle bin. I couldn't find it, but it's right there. I don't know why. I think I did that live too before when I was stuck. That was so weird. So anyway, we can get rid of this output text. And yeah, so we got a yes. All right, but we were expecting a no. Got a yes, but we were expecting a no. Now that's very interesting. How did that happen in this test case? In this input 3? How? So this is present somewhere, it seems. Isn't it right here? 4, 3, 2, 4, 5, 6, 7, 9. Now, why would that happen? I think the regex that we built here has one too many characters, something like that. It's shucks, man. we can modify this slightly just for the time being. Maybe just the logic is incorrect. I don't think so. I think it's pretty close. So you got these dots. You join. So this big C and this little c is 1,004. So you got 996 of these. 1, 2, 3, 4. And the idea is that if you move this thing over somewhere, well, where's the match? Let's do it that way. Let's like return the match if we can. Let's just go ahead and, oops. Let's go ahead and print this match. Let's see what we get here. Let's see what we get here. Okay. Wow. 1, 2, 3, 4. The pattern we're looking for is 1, 2, 3, 4, 4, 3, 2, 1. So it should be 1, 2, 3, 4. Now, somewhere in here, all right, let's take this. Throw this into our text editor. It's all in one line. That's the thing. So it's 1, 2, 3, 4. Found it. 4, 3, 2, 1. That should be 996 characters away. What's the next one? 5, 6, 7, 8. 5, 6, 7, 8. And then finally 8, 7, 6, 5. Yeah, that's it. That matches. How is this not a match, though? Is my algorithm better than their algorithm? Is that what's going on here? What do you mean? How is it even possible? Let's go back to the beginning here. 1, 2, 3, 4. Okay. Space. Then 4, 3, 2, 1. Another space. Then what's this thing they're looking for? 5, 6, 7, 8. Space. And the last one, which is 8, 7, 6, 5. And each of these, 1, 2, 3, that's what we expect. Each of these have exactly the same number of characters, and it's selection 996. 996. 996. This is a wrong test case. This is the wrong test case. There's no way. This is a match, man. You gotta be kidding me. You've gotta be kidding me. No way, dude. Hold on. There's no way. Let me see this. Take this string, right? This is the row that it's on. And search this here. No freaking way. What? Cannot find this. That's not true. Oh, I guess because, oh, I see. Okay, we don't know exactly which line it cuts off on here. I guess there's a point somewhere in between where it breaks off. Well, what are the odds that, you know, I don't know, if we take like 1,000 characters, 200 characters or something, or a whole bunch of characters, what are the odds that we find this? No, not even that one. How about we reduce this something else like this? Really? Must be all the way on the end? You're kidding. It's not even... There it is. No. 8425. It's the only one. One, two, three, four. How about just 8? One, two, three, four, 8. Not even, no. Nope. Oh, there's a few of these 1, 2, 4, 8s. 1, 2, 3, 4, 8. How about 8, 4? Just that one. Okay, I found that a few times. Oh man, this is hard to find. What did I do? I did something wrong here. 1, 2, 3, 4, 8, 4, 2, 5. This is the only one. So it's got to be on the edge here then, somewhere on the right side. Oh yeah, okay. Somewhere there's a 1, 2, 3 here. Oh, there's 1, 2, 3, 4. Oh, it's right here. Oh. Here's the problem. You see that? This has got to be on the same line. Oh, you're kidding me. Wow. I did not even think of that. Because this will match further to the... Oh, wow. That is... Wow, okay. Talk about a test case. I missed that. Oh, I can't believe I missed that. That's so bad. How do I... Oh, I didn't even think of that. How do you... What? You got this 1, 2, 3, you got this 4x4, 16 characters. So, because you're put this on one dimension, no, but the grid forbids that you have partial matches over the edge, even though the dots should be over the edge. Like the dots don't matter, but the partial matches do. Oh, I did not even think of that. Oh my goodness. So how do we ensure that doesn't happen? I guess what we've got to do is put pipes in between the joins, and then we can add an extra dot at the end. I think that's might be the correct way to do it. So I'll show you what that would look like. It'll definitely help work for this test case, which means it'll pass the test cases they have. But I'm not sure if that'll work for the general case. Basically what you do is you add a pipe when you join. And we happen to know pipe is not something that we're searching for, right? Because they're all digits. And then you say increment this at the end to account for the pipes in between. And that ought to do it. Now let's get rid of this now. Let's also change our environment to 2 instead of 3. Okay, 2 instead of 3. And now let's run. Let's delete that first as well before it starts writing to it. Yes, yes, no, yes, no. That's what we expect. So, alright. I mean, you got me. I don't know. I didn't think of that case. That's like such a strange case to think of. And I guess I don't know what to think. I don't know. I don't know what to say. I don't know what to say, man. I done goofed, I guess. I have no retort. No explanation. This just prevents that from happening. It's like the only I think it's the only thing I missed. Might be the only thing I missed. I don't know, man. I thought it was so clever too. I thought it was so clever doing this. Man. Shucks. Could you do that? You could only do that on the rightmost side. Yeah. It only works on the right side. You can't do that on the left side. Yeah. Just yeah. Okay. All right, that was it. All right, fine. You know, whatever. Whatever, we got it. Whatever. I don't know what to say. I don't know. I'm kind of a little sad that I missed that, but that was pretty. That was a pretty, like. I guess I should have thought of that. Yeah, I should have thought of that. Yeah, I just didn't think of it. I should have known. I definitely should have thought of that. Yeah. I thought I got close. I was so close. I was so close, man. I was so close. Because, what is it? You needed, I thought of the case where if you move the thing all the way to the right, would it still work? But I didn't think of the case that you move it one extra to the right. The match began, because it could actually match on 2 different lines within the part that's not supposed to be on 2 different lines, and then you have a finish here. Well, anyway, that was pretty efficient, I think, solution. Pretty efficient. Actually, thinking it up was kind of quick too, kind of efficient as well. And the code, I think, is it's all strictly functional. You can see it's you have these patterns of this to this. You have arguments to this function, and then these are all just functions themselves. And then so this is just a composition of functions with one if statement. So it's functional. So I think we're getting closer to idiomatic Clojure, I think. I hope. I suppose, I guess. This is a bit of a hack. We know that this character will never be present, but what you would need otherwise to do this problem, if it was like arbitrary characters, is you would need a sort of a escape character or something. Some way to like delineate between rows, so that way you don't include them in your regex matches, the things that are split over rows. Yeah. It's a little bit awkward because of, like I said, if this is arbitrary characters, you need to have some character that wouldn't. So this actually wouldn't work for an arbitrary character set, which is like, I don't know what to think of that exactly, what to make of that. So anyway, that's cool. So yep, thank you for watching, and we'll go to the next one. So that's the 9th problem we looked at, and we'll look at one more tonight, and then I think we'll start our project. Yeah, I'm putting together a website, and it should be interesting. Should be a good time. We'll get that going shortly.